Welcome to We Exist for a Bigger Reason. All food and beverage manufacturers need a water handling strategy to secure water supplies and to protect profits. My name is Alan, and I hope to show you that part of that strategy needs to include reduction of water consumption. Goal number 6 on the UN list of Sustainable Development Goals is called clean water and sanitation. It's not number 6 because it is prioritized as number 6. The UN doesn't prioritize these goals, and neither does Alfa Laval. The reason we talk about water is that it is a key ingredient in our customers' products, and they use large amounts for cleaning, specifically cleaning in place. There's a lot of talk about water scarcity, and the UN estimates that by the year 2050, 6 billion people would live in areas of water scarcity. But how can a planet that is covered in water, that's why we call it the blue planet after all, how can we have too little water? And do we have too little water? See, the thing is that the water on Earth is mostly salt water. In fact, only 3% or less than 3% is fresh water. And fresh water is what we need for consumption. Of those 3% of the total volume of water, most is found as ice, polar ice caps, glaciers, and some of it is in difficult to reach groundwater areas. At the bottom line, less than 1% of the water on Earth is available to us for consumption. But that is the same amount of water that we always had. So why is that a problem? Well, because of increasing population. Again, with UN numbers, by the year 2050, it is estimated that we will be 10 billion people on the planet. For that, we will need 70% more food, and we will need 30% more water. So we have been in a tight spot before, where we have a scarcity of some resource, water or food, and we always seem to find a solution. We call the engineers in, right? Personally, I have great faith in engineers. But not all the solutions that engineers come up with are equally good. And one example of that is the Aral Sea. This is footage of the Aral Sea as it is disappearing. It used to be the 4th largest freshwater lake on Earth, but that was until it was decided to divert the rivers that fed it and use the water for irrigation of farmland. Today, the Aral Sea is more sandbox than sea. Let's have a closer look at the problem or the challenge that we are facing. This is a world map of current water stress. It's not a faraway future. It is what the situation looks like right now. So what we see on the map, what the colors are indicating, the gray areas are areas where almost no people live, so it hasn't been mapped. It's areas like Greenland and the Sahara Desert and others. Then we have the light yellow areas, which are areas with almost no water stress. It seems to be most of the world. And then we have the red colors, with the dark red color being the highest water stress, of course. As mentioned before, this is now. It's not the future. Intuitively, we understand that water stress appears in dry, warm climates, such as the Republic of South Africa. And in 2018, they were running out of water. They knew when it was going to happen. They called it day 0. That was the day when the 4 million people of Cape Town would literally run out of water. They tried all kinds of things to provide drinking water, including a plan to haul an iceberg to South Africa. They didn't come that far because on the very day that they ran out of water, on day 0, it finally started raining. It was a big scare, and all the plans are still on the desk because they know this is going to happen again. Last year in the United States, 83 out of 204 water basins saw water shortage, and 40 out of 50 states expect to see water shortage in the near future. A little closer to where I am now in Denmark, we have Norway. And Norway is cold and usually quite wet, and they use a lot of hydropower because they have enough water. But twice this year, the authorities have asked the people of Oslo to save water because they have a drought. Now, it sounds like we have a bad situation one year in this place and another year it's another place and it continues like that. But actually, it is a continuous situation. If we go to France, the consumption of water has for more than a decade consistently been higher than the influx of water to France from rain and rivers. So in principle, if they continue like this, they will eventually run out of water. What is the risk to businesses of running out of water, or at least having to reduce production because of having too little water? Well, one example is Coca-Cola. And as you probably know, Coca-Cola manufactures syrup concentrate in a few factories and then ship it to bottling plants around the world where they make the final beverage and supply the local area. One of those bottling plants was in India, where local people started protesting in the streets, claiming that Coca-Cola was stealing their groundwater. And in fact, Coca-Cola was ordered by court of law to shut down the bottling plant and replenish the reservoirs from which they had extracted the water by twice the amount that they had extracted. So, of course, being ordered to shut down a bottling plant, the financial implications are clear. But to a company to whom branding is everything, you could only speculate on the cost of getting in the media, including the Financial Times, with a story like this. But okay, you may be thinking, India, warm, dry, loads of people, right? So let's go to a place that is cold, wet, and there's hardly any people, right here in Denmark, where I'm standing now. 20 minutes away from here, we have Carlsberg, making probably the best beer in the world. And they have succeeded in reducing the water consumption when they do so. They have reduced from 2.9 to 1.4 hectoliters of water per hectoliter of beer. Of course, they have done many different things to achieve this goal. One of those things being reuse of water. They have built what they call a technical water management plant, and that is quite an investment to do so. In Denmark, we don't have any immediate lack of water. It usually rains, but still it seems to be a good business for Carlsberg. The brewing industry is highly competitive, and Carlsberg is a listed company. They don't do this for the sake of their blue eyes. They do it because it makes sense business-wise. And my guess is that if it makes sense to do so in Denmark, it makes sense everywhere. But of course, remember, there is a cost to doing this. There's the initial investment, and there's the running cost and maintenance and power consumption and so forth. What if we operate in areas where we don't have any water in the first place that we can reuse? That is the case in many places. Then we can use desalinated seawater. That is a technology that is used around the world, and I think that it is a technology that we need. It's here to stay, but it's quite expensive. According to Coca-Cola, for example, they say that the cost of using desalinated seawater is 5 to 7 times the amount of using groundwater. So there's a significant cost to it. On top of that, there's also a big footprint on the environment. When you create desalinated water, the water intake from the local ecosystem does a lot of damage, actually. And then you have the treatment of the seawater, for which you use a lot of energy, you use a lot of chemicals, and every time you produce 1 liter of fresh water, you also produce 1 liter of highly concentrated brine, being a very concentrated salt mix, but that includes heavy metal and toxic chemicals, and that is also let back into the ecosystem, and again, doing a lot of damage. So it's not going to win you any popularity contests to use desalinated seawater, on top of it being very expensive. So very expensive, what do I mean by that? Well, in one example, in Melbourne, Australia, there are about 5 million people. They invested in a desalination plant for the price of $3.5 billion US. For that, they get 150 billion liters of water, which covers about a third of their annual consumption. Now, the $3.5 billion US is the construction cost, but on top of that, they need to run it, they need the power, they need the chemicals, they need the maintenance, everything on top of that, of course. But even so, the $3.5 billion US is difficult to relate to, I think. And just in an attempt to relate it to something, I can tell you that in Denmark, we're also more or less 5 million people. And we spent the same amount, $3.5 billion US. And for that, we got the bridge that you see on the picture now. And every time we pass it, in either way, we have to pay $35 US. And we're going to do that for 35 years to pay for that bridge. So 35 years, that is how much of an investment $3.5 billion US is. Most of us probably operate in areas where we have an already established water distribution system, meaning pipes in the ground. Most of those pipes were put in the ground decades ago. And we have to remember that we're going to need at least 30% more throughput in those pipes. And I say at least because people have a tendency to clump together. We call it urbanization. And food and beverage manufacturers tend to want to be where the customers are. So in those areas, we are going to need at least 30% more water. Now, putting pipes in the ground is expensive. The maintenance is also really expensive. And in fact, it is so expensive that it is often neglected, with the result that in the US of A, with a population of 340 million people or so, every year, almost 20 million people get sick from contaminated water. So far, we have only talked about securing the water supplies. We haven't even talked about using the water. Food and beverage manufacturers don't just have water standing around in barrels, they do stuff with it. And the first thing that they do, even when they consider the water a good raw material, they often have to pre-treat it, descaling, for example. And at least they pump it, and for the most part, they heat it. In fact, the heating of water is one of the biggest costs that you have in a food and beverage manufacturing plant. And certainly with the current energy prices, that is a big cost. Then in most places, you can't just discard of water. You can't just pour it back into the river. You need to treat it before you do so. And when you look at wastewater treatment facilities, you will notice immediately that you need a lot of land. You will need a lot of concrete constructions. You will need a lot of expensive equipment. And of course, you need the people to run it and maintain it and the power to do so. And what we actually often see and hear from, for example, from dairies, is that it is actually the bottleneck in increasing production. They would like to increase production, but because the wastewater treatment facility is too small, they can't increase production. So it is a significant consideration. Before we start producing more fresh water, why not reuse the amount of water that we already have? But because there's also a cost to reusing water, why not reduce the amount of water that we use in the first place? If you don't use it, there's no cost to it. Not just the purchasing price of the water, which tends to be low, but also all the costs that we mentioned before. Be water smart, reduce water consumption. Now, I'm pretty sure that all of us who have children, we ask them to turn off the water tap while they are brushing their teeth, and we probably do it ourselves. And we should. It's a good thing. We should keep doing that. But if you're watching this, then chances are that you work in the food and beverage manufacturing industry, meaning that every day you can influence decisions that will save thousands of times the amount of water that your children can save at home. So the question is, what will you do? Thank you for watching.